and welcome to another edition of the Poultry Network Podcast. My name is Tom Willings.
And I am Tom Woolman.
Today's episode is focused all on the topic of Campylobacter. Now, you might not have heard of Campylobacter for a little while because 10 years or so ago, it was in the news, a regular feature on the back of an FSA study of 2014 and 15 that found a high level of prevalence in chicken on supermarket shelves.
Yeah, there was a time really where it was ubiquitous, wasn't it? You couldn't get away from it at all the conferences. That's what people were talking about, and it was all certainly retailers were really interested in terms of how you were managing your Campylobacter schools.
And then the supply chain, I had a quick stint in retail around that time. And supply chains turned themselves inside out at farm level and in the process, in the cool chain particularly, in packaging to make amends or to mitigate as much as possible. But it remains a food safety issue, and we're joined today by a guest who knows an awful lot about the subject. So just allow me to introduce to you all Professor Brendan Wren. Brendan's the co-director of the Vaccine Centre and co-director of the GlycoCell Engineering Biology Mission Hub at London School of Hygiene and Tropical Medicine. Brendan, that's one enormous job title, but it speaks to the power of your knowledge, sir. So welcome to the podcast. And why is Campylobacter back in the news?
Good afternoon, Tom. Well, Campylobacter never went away. It's a leading cause of gastroenteritis worldwide and leading cause of gastroenteritis in the UK. It's estimated that 500,000 cases in the UK alone at a cost to the UK economy of over £1 billion. And that's the equivalent in the US, where it's about $7 billion a year, and the EU. So it's never gone away. It's still a really persistent problem worldwide.
That's an astounding number. So that Campylobacter could cost the UK £1 billion a year in terms of.
Indeed, yeah, and there have been many independent estimates that it is at least £1 billion a year to the UK economy. So that includes lost time at work and hospital costs and everything else. So it's still a major issue.
So did I read in sort of research for today's episode that something like 70% of gastroenteritis or cases associated with food poisoning relate back to chicken and Campylobacter?
They relate back to Campylobacter. It's not always poultry that is the problem for Campylobacter. It can enter the food chain via other routes, but certainly we know that that's the main route, and the consumption and handling of poultry is a big issue.
What's so special about poultry? Because I was reading that Campylobacter is present in all sorts of guts of all sorts of animals.
It is present in many different animals, but it's elegantly adapted to the crop of avians, so not just poultry, other birds. And part of the clue is the optimum growth temperature of Campylobacter is 42 degrees, which is the body temperature of birds. Obviously, humans is 37 degrees. So it's clear that once a few cells of Campylobacter get into birds, we know it multiplies really rapidly, and there can be trillions of different Campylobacter present within a crop of a bird. So it really expands massively. And yet, just 100 cells causes severe bloody diarrhea in humans and potentially other complications.
Mm. So going back to the introduction, when we were talking about when the industry was focusing quite heavily on Campylobacter in the past, and there were a number of measures which were brought in to contain the spread of Campylobacter, some of which Tom has referenced, and I remember some of the specific measures that came in on farm. There were things like boot barriers. That's really when boot barriers became mandatory. Single boot barriers. We now seem to have double boot barriers in a lot of places as well. And also at that stage, the industry was mostly doing two thins in a broiler crop. And after a thin, you do get a spike in terms of Campylobacter. And so certainly in retail, the industry has moved to a one thin program. where birds are only gone in for to take some out at one point in the course of the crop. So, and I think probably up until this point, a lot of these measures have reduced the levels from where they were, and the situation is managed and it is monitored, even though it isn't in the news. It still is monitored by all these businesses and by retail. But the reason we wanted to talk to you, Brendan, is that you've been doing some research which is helping to us to understand even more about how Campylobacter lives and how it spreads, and might offer some clues in terms of how we might be able to deal with it more effectively in the future.
Yes, Campylobacter is still a problem in poultry houses and farms, and the statistics show that. I've been studying it for 30 years, mainly, how and why it causes such acute disease. And it really is an enigmatic pathogen with many peculiarities. One of the main peculiarities is it's the leading cause of gastrointestinal disease in the world. It seems to be omnipresent, but it's actually oxygen sensitive, so it doesn't grow in the atmosphere. So we call this the Campylobacter conundrum or paradox. How can it seem to be present everywhere, but it doesn't grow in the air? We need special conditions to actually persuade it to grow. And it doesn't generally spread from person to person. So there's this real paradox as to how Campylobacter is such a leading cause of disease still, and yet it apparently doesn't like surviving in the environment or atmosphere.
Because you're right. Because if I was going to talk to people about gastroenteritis and that sort of thing, people start talking about norovirus and certain viral things, but these are things that spread from person to person. So if one person's got it, then everyone else is acutely aware that they might get it as well. Whereas with Campylobacter, it's not like that, even though actually the level of prevalence is probably much higher.
Indeed.
And your research, Brendan, points to the humble amoeba. Is that right?
It does. So the humble amoeba is, I guess, about 20 times the size of Campylobacter. Amoebae are everywhere. They're omnipresent in water environments and soil environments. And, they're ancient, simple unicellular organism. And basically their diet is to eat bacteria. So they have pseudopods that encapture bacteria, eat them. And of course, bacteria aren't happy with this. So they will, over a long evolutionary period of time, try to counteract this. And our studies have shown that Campylobacter has a very intimate relationship with Amoebae. It counteracts all the toxic threats that Amoebae have in kind of like an evolutionary arms race. And it's under the microscope of looking at Amoebae and stained Campylobacter, we can see the Campylobacter fighting back. So this is a long evolutionary process that these two organisms have had. And we think that this could be the missing link in terms of understanding why Campylobacter is so prevalent.
I may have misunderstood the brief, of course, but did I understand correctly that the Campylobacter is actually living inside the amoeba?
It does, and it's quite happy to be there. And then when the amoeba form cysts, which are these very durable cells, almost like spores, Campylobacter is still in there. And what our lab studies have shown that when Campylobacter comes out the other side, it's actually more invasive, it's more aggressive. So living within the amoeba makes Campylobacter that more aggressive. So once it reaches the poultry population, chickens, it can really take off.
So it's like a Trojan horse. The amoeba is the Trojan horse for the Campylobacter. It's living in a protected environment, improving its sort of durability, and then out it pops with, how many multiple times more genetic is it? I can't say the word, but invasive.
There's a few tongue twisters in this podcast,
aren't
there just, for a humble egg guy, yeah.
You've got it exactly right. So it acts like a Trojan horse, the amoeba. It carries the Campylobacter in. Amoebae seem to be everywhere as well. And once Campylobacter comes out the other side, we're shown in a lab it's that much more invasive, aggressive, and and that's where we believe the problems lie.
So how do we better then detect it for one and get a true read on how much is there and then combat it?
So people suggested Amoebae in the past as a potential way that can be in poultry houses. But in the past, people tried to culture Campylobacter from Amoebae. And as I mentioned, Campylobacter is difficult to grow and they failed by that. But we use a more PCR sensitive approach, and we can detect Campylobacter within about 30% of wild Amoebae. These aren't even ones associated with farms. So we think that this has been missed. We have a more sensitive way of actually detecting the Campylobacter in Amoebae, and then the percentage numbers were a lot higher than we expected. So I guess we're proposing as a fairly simple solution would be to obviously remove Amoebae from any opportunity within a poultry house. So this could be through drinking water, because Amoebae are quite happy living in drinking water. Better filtration, UV, it's simple hygiene measures would help, not just to reduce Campylobacter, but if what we're saying is true, then actually we should be looking at removing Amoebae, and that would remove the Campylobacter.
Does this also somehow help to add to our understanding of why we see a peak in summer months, in particular for Campylobacter?
Yes, that's one of the other mysteries about Campylobacter. The incidence in the summer months goes up tenfold.
I thought it was barbecue season that was the problem initially, but the problem is there is more Campylobacter around as well, isn't it?
Yeah, there's just such a huge number, and you can almost set your watch by it. But it's not barbecues, because in wet summers, when there's been no barbecues, you still get the increase. So for what I used to think it's barbecues was the explanation, but clearly we think there's something else. And I guess what's key about Amoebae is that they bloom in the summer months, that their numbers naturally go up. So that could be a partial explanation for why Campylobacter is high in the summer months. But that's circumstantial evidence. We're looking forward to try and really prove all of this.
Yeah, I want to just leap back to the more sensitive detection that you just mentioned there, and there's a little alarm bell ringing in my mind to think that there will be farm assurance protocols in place at the minute, and the same in factories, and testing of finished product as well, all using certain sets of technology. But are you pointing to a future where perhaps we need to acknowledge the type of testing that's being conducted, because they're going to give very, very different results, and with more sensitive testing, what do you think the practical measures, not just on farm but right the way through the chain, ought to be to deal with higher rates of detection?
I think I may have misled you there. I think these methods of detecting Campylobacter within the food chain and from farms and that is pretty good. I was referring to detecting Campylobacter within Amoebae. So in the past, people tried to culture it and generally failed. But we're saying with PCR sensitive methods, we can actually detect Campylobacter in Amoebae. So I think at the moment through the food chain, they really only look at the poultry or after thinning for Campylobacter. But we're at an earlier stage. There's this missing part of the life cycle of Campylobacter. If you look for it there as sensitive methods, we believe you can find it, and that might be a better improved intervention method. Whether we're starting to also think about screen. There are many different anti-Amoebae agents such as chlorhexidine, quaternium ammonium compounds, and many others. So I guess what we're proposing that simple measures early on that can eliminate as much Amoebae as possible will also simultaneously remove Campylobacter.
Yeah, so it could well be that at the moment when people are doing water tests on farm, fairly typically you might do one early on in the crop when you're brooding and the temperature in the house is warm and the water's warm as well and the flow rate is low, and and you're testing it for the TVC, the total viable count, and also for stuff like Pseudomonas. So it could be that actually we start looking for Amoebae in that as well. I don't know how easy that is to do in the sort of labs that we've got at the moment, or whether it might have to have a bit more imagination in terms of how we actually test for these things.
Yeah, actually, Amoeba are quite difficult to culture as such. So, but maybe we're also looking at PCR sensitive method to detect Amoebae. That would be a lot simpler. But certainly, I think the issue is trying to culture Campylobacter from Amoebae is difficult. You can culture Pseudomonas, E. coli, Salmonella. These are bacteria that naturally grow in the atmosphere. Campylobacter doesn't, so that's why it's a tough nut to crack.
Mm.
So we've got a takeaway message for farmers, which is, well, everyone in the chain, all about hygiene, and that this isn't as easy to eradicate as perhaps once first thought, and we're going to have to dig a little deeper. What about your research? What's the next step for your research, and what's your sort of call to the industry?
Well, I'm a lab scientist basically, so I did visit a poultry farm recently. Tom Warnham and his sister Caroline Scott, they very kindly showed us around the poultry houses, which was an eye opener for me and my colleagues, and they've allowed us to take samples, which we're investigating at the moment. So what we plan to do is to do this on a systematic basis at a number of farms, particularly farms that have had a history of Campylobacter, and even free-range farms as well, and to really prove our theory, and then to start to implement some measures that we could use, whether it's targeted anti-Amoebae agents, disinfectants, or whether it's more simple, hygiene measures that could be done. Once we really, I was just so impressed to see poultry houses a sealed unit, and to me, it's a problem of seeing what goes in and what comes out, and so we've obviously tried to detect it at the litter, ventilation, the food, the feed, and we suspect that actually the drinking water may be of importance.
Mm. And that's interesting because there's been a huge amount of focus in the last 10 years on drinking water. If I think back to when I started in poultry, a lot of people weren't doing anything for hygiene with their drinking water. Some people were throwing a few chlorine tablets in and hoping for the best, whereas most farms now would have a system where they are select dosing a chemical or different chemicals, chlorine dioxide or hydrogen peroxide at set rates, and people are testing more. And so I think this could be quite an interesting evolution along the way for water hygiene in poultry. Yeah.
I agree, yeah.
Yeah. Brilliant.
Well, that sounds like a good way to end the episode. So Professor Brendan Wren from the London School of Hygiene and Tropical Medicine, thank you so much indeed for imparting your knowledge, for joining us today. To you, I hope you've enjoyed listening and taken something away from today's interview. A reminder that if you're not already subscribed, please do so, and make sure that our podcast episodes drop into your inbox every Friday. Until next time, thank you.
Thank you.